Hello students, this is lecture 8 on alcohols, phenols and ethers. So here we are going to prepare alcohol by the use of Grignard reagent. So I am writing over here preparation of alcohol using Grignard reagent. So now first of all we need to understand what is Grignard reagent. The general formula of the Grignard reagent is written like this. Okay, I will write Grignard reagent. General formula is RMgX. Means if I want to know the more example of the Grignard reagent, then this is it is like this: CH3 magnesium chloride, or R group could be anything: CH3, CH2, MgBr. This is also a Grignard reagent. General formula is RMgX. X could be any halide. X could be uh, fluorine, or it could be a chlorine, bromine, iodine. And methyl R group could be any alkyl group. Okay, more examples you can derive. So these are the some of the simple examples of the Grignard reagent. So reaction, so preparations of the alcohol using Grignard reagent. So here first method is reaction of Grignard reagent, GR I am writing, with carbonyl compounds. Carbonyl compounds. In bracket, I will write it to be aldehyde, aldehyde and ketone. Let us learn the advantages of these reactions over reduction method. Mm, So first I will write a general reactions. I will write a carbonyl compound like this: C double bond O, okay, C double bond O, and this way. I'm writing this in general because here this bond, let's say this is a group A and this is group B. It depends upon, like, if A is alkyl methyl group and this is also methyl, then it will be a ketone. If this is methyl, this is hydrogen, then it will be a aldehyde. So in general, what I'm writing is this in this manner. Okay, it could be this also. It could be CH3H O, then it will be a aldehyde. Or if it is like this, then it will be a formaldehyde. Or it could be this also, both alkyl group. It could be ketone also. Okay, many more. You can extend this chain further. You can write C2H5 and methyl over here. So it will be butanone. So it depends upon what type of group is attached over here. In the whole mechanism, in the whole reaction, these two groups are going to remain intact. Which two groups? These two bonds are going to remain intact, and only change will happen at this double bond. So I am reacting this with a Grignard reagent RMgX. The product what we get is, see, these two bonds are intact. Um, Here this is a negative. Okay, first I will write this: we are getting OMgX. Okay, OMgX. Further, if I do the hydrolysis in the presence of, hydrolysis is breaking of bonds using water. So what I get is this this ROH. Now this R which is attached over here, okay, this R which is attached over here, this is from Grignard reagent. Okay, so if I go into the mechanism, okay, let's learn about the mechanism. how the things are happening over here. Only thing mechanism is very simple. You have to just identify which is the negative part and which is the positive part in that case. Mechanism. This is the carbonyl compound I'm writing. It will depend whether it is a aldehyde ketone based on these two groups. I'm reacting this with the Grignard reagent RMgX. Now in this case, this is the negative part, this is positive, this is also negative part. Now this is the R group which is attacking on this carbon because this carbon is partially positive compared to the other groups because this carbon is attached to the oxygen which is electronegative, right? It is going to pull the electron and that is how this bond is going to attack. Now in the second step, what is going to happen is negative charge will be developed over here. Okay, this bond will be breaking up with this bond will break and this negative charge is going to attack on this. Okay, means this reaction gives you R attach over here and OMgX. Further, if you do the hydrolysis, further if you do the hydrolysis, H2O in the presence of acid, what we get is R and this O is converted to H, right? And the byproduct what we get over here is it will be MgOH X. Okay, this will be the byproduct over here. And this is the general mechanism. Let us take some examples and let us understand what would be the products using this. So if I'll start with the formaldehyde. Okay, I'll start with the formaldehyde. This is the carbonyl. These are the two hydrogens, and this is the formaldehyde, or we say this is to be a methanol. Aldehyde, one carbon system, also known as formaldehyde. If you react this with, let's say, a methyl magnesium bromide, then the product what you get is this is the intermediate product. These two groups hydrogens are going to remain same. Here the methyl group R group from the Grignard reagent, and here it is OMgBr. Further, if we do the hydrolysis, further after doing the hydrolysis, we just write H plus and water. What we get is this CH3OH. Means here the product form is ethanol and it is primary alcohol. Now let us take little higher aldehyde, that is one is methyl, this is H over here, double bond O. Now in this case the name of this aldehyde is ethanol, and because there are two carbons, okay, this is ethanol. If I react this with like I'm choosing this to be methyl because it makes my work simple over here. You can choose this to be ethyl, propyl, any alkyl group provided you can attach it to this carbon. Now this is methyl magnesium bromide. Further, these two groups are going to remain intact and this will change to OMgBr plus methyl. So here after doing the hydrolysis, what we get is CH3, CH, this is CH3 and this is OH. Means byproduct is there, byproduct is also there, but this is the main product. What we get is a propan to all, and this is the secondary alcohol. What we are getting is a secondary alcohol. I'll take this top. Oh, yeah. This is a secondary alcohol. And the third, I will take a ketone. I will start the reaction with a ketone. You can choose any other ketone. I am taking the simplest ketone. And let's say this is methyl MgBr. What is this is going to give me this way. Now this methyl which I am attacking over here, or I'll take a ethyl group also, not an issue. Let us keep it methyl only. Here I am attacking a methyl, and this is OMGX because these two groups are same. This methyl is from the Grignard reagent, and this is going to be OMGBr. Okay. So further after hydrolysis, what we are going to get is H plus in the presence of H2O. What we are going to get is this OH. Now this alcohol is a tertiary alcohol, right? Tertiary alcohol. Name is if I start naming from here, this is the longest chain 1, 2, and 3. Then name will be 2-methyl. Name will be 2-methyl propane 2-ol. Now let us understand the difference. Okay, if we just see this, let us understand the difference. You can understand it together. Like methanol or aldehyde gives the primary alcohol, the simplest one carbonyl compound. And any aldehyde, if you take any aldehyde other than methanol, it will always give you a secondary alcohol. And ketone, if you take, then you will get the tertiary alcohol. So if I want to summarize this, then from this reaction, formaldehyde gives primary alcohol, and any other aldehyde. Okay, aldehyde. This is also aldehyde, but I will write aldehyde other than will give me a secondary alcohol, and ketone is going to give me a tertiary alcohol. So the advantage of this over reduction method is that we can prepare a tertiary alcohol. In the reduction method, we were able to prepare only primary and secondary, and there was no scope for the preparation of the tertiary. When we did the reduction of the carbonyl compound or the reduction of the aldehydes or a ketone, reduction of the aldehyde is to give us a primary alcohol and the ketone is to give me a secondary alcohol. But there was no scope for the tertiary alcohol. So if you want to prepare the tertiary alcohol, you can take the help of the Grignard reagent with a carbonyl compound, that is aldehyde and the ketone. So I'll end this class over here. See you in the next lecture. Thank you.